our life searching for the sense of belonging. Some people die before they fulfill their desires. Such a waste of existence.
Anxious Earth is rising. Anxious Earth is rising. I'm so happy.
We spend our life searching for the sense of belonging. Some people die before they fulfill their desires. Such a waste of existence.
Hi, this is the Double Tribble channel. My name is Ron, and I live in rural New Hampshire, surrounded by forests and wild animals. Wait, I'm still a cartoon. Hold on.
Ah, that's better. That's better. It's been a while since I've streamed, so bound to make a few mistakes there. I forgot to change back from being a cartoon, so I can be excused for that, right? It's been a long time. It's been a couple weeks since I've streamed, so I got to get back into the all the technical stuff. I'm gonna spend about an hour before the stream trying to get set up because I'm just not used to everything. So it happens, and then I forgot to turn myself back from a cartoon into a real person. So that happens. I don't have much planned today. I'm going to talk about gravity, I think. And I have some Corrigenda I need to address and AI videos, which should be fun. But not sure about the AI videos. Gravity, I like talking about gravity, so I'll do that. That's science. I labeled this as I think I labeled this as just chatting because I'm not sure. Just chatting, yeah. And also, if you're watching this on YouTube or on a VOD somewhere, this is a live stream. And it's going to be kind of whacked a little bit because it's live, right? So I'm going to make mistakes and stuff. And it's probably going to be labeled gravity. And so you'll see, oh, gravity. I want to hear about gravity. And you'll come to the thing and you'll see me talking about cartoons and stuff instead. So just fast forward to whatever part of the thing that you want to watch. And usually at the beginning, it takes me a while I talk about my garden or who knows, what I've been doing and all that kind of shit before I get into whatever the actual topic of the stream is. So that's what I'm doing. Oh, and I'm NeuroD too. That'll come up too. You'll notice that. I've got social dyslexia. So, if that bothers you, go somewhere else. I don't want you here anyway. But if you're not a bigot, please stick around because this is I'm going to be talking about geeky stuff like gravity and Sora 2 came out. I finally got my invite. I found an invite code to Sora 2, so I've been making videos. So maybe I'll show some of those. And you actually just saw one right at the very beginning. Did you notice that? I'll play it again in case you missed it. In case you weren't paying attention. Let me do that again here. Can I do that? Yeah, here. Let's see. Shut it off. Here we go. Okay, I think this will work.
Oh, hi. This is the Double Tribble channel. My name is Ron, and I live in rural New Hampshire, surrounded by forests and wild animals. Wait, I'm still a cartoon. Hold on.
Isn't that cool? So that's Sora 2 did that. All I did was take that first little picture. This picture here. I'm gonna. Oh shit. All right, I'll show you this picture here. All right, that's that picture that I do at the very beginning. All I did was take that picture and give that to Sora 2 and gave it some things to say and said make a video, and it did it. It's so smart. So I'll do some of that later. Oh, I've got an ad running here. I don't care. Nobody's watching anyway. Yeah, that's kind of a problem. If you're watching this on the VOD, sometimes I like to stop if there's an ad playing. Twitch plays an ads while it's being broadcast live, but the ads don't get into the VOD. If it doesn't get into the video that gets uploaded to YouTube. So if you're watching this on YouTube, you'll see me say, "Oh, the ad's playing," but there's no ad playing. So on the VOD, but right now live, there's an ad playing right now, and the people who are watching live can't see me talking right now, if there is anybody live watching me. So all right, looks like the ads are over. So all right, gravity. Yeah, I want to talk about gravity a little bit. I did. Well, let me adjust the Corrigenda first, because the Corrigenda that I have to do, some of them have to do with my gravity streams. I did a stream on. I did a couple big streams. I did a stream on space-time diagrams and the twin paradox, which were really highly technical and took a lot of planning, but they had a lot of stuff in them. But there were some things that I didn't put in there that I wanted to put in there, or I wanted to mention or whatever, and didn't mention, and I wanted to mention now. A couple things. One of them was, what did I forget to mention? Oh, there's a thing when you're talking about special relativity. You guys know about special relativity, Einstein, all that kind of stuff. How when stuff moves really fast, things happen, weird things happen. Time changes and it shrinks and all this kind of stuff. Time dilation. Well, when you're talking about two different reference frames, like if you're just sitting still, right, and some other thing, some other object or person or whatever is going really fast, half the speed of light, things are going to happen weird. Time's going to slow down for them and all that kind of stuff. And when you talk about the time that observer in that other reference frame is experiencing, you call that proper time for the observer. And then like if normally what you do is you set it up so that, like in a space-time diagram, whatever, you're the rest frame, that you call that coordinate time. And then for an observer that's moving and you want to talk about the time that they're experiencing, you call that proper time. So I wanted to talk about that. Also, I kept saying I didn't use the word velocity right at the beginning. I kept talking about vectors. It's the same thing, but it's vectors more general. And I didn't use. I don't even know if I even used the word velocity. I think anybody who was watching that is kind of advanced stuff. So if anybody was watching that, they already know that anyway. But velocity, there's speed, which is how fast you're moving without in any particular direction. You could be going, 100 kilometers per hour, and that's your speed. But if you say velocity, then you got to say what direction you're heading. You can say I'm going 100 kilometers per hour. That's my speed. If I'm going 100 kilometers per hour in this direction, then that's a vector. That's my velocity. And when you change your velocity, you don't have to change your speed to change your velocity, which sounds kind of funny, but that's how it works. You can change your velocity without changing your speed by changing your direction. So if you're going 100 kilometers per hour, I think I explained that, but I didn't use the word velocity. I used the word vector, which is the same. It's the same thing. But anyway, I just wanted to say that velocity. Some other stuff that needed to be corrected that I did not. It had nothing to do with general relativity and all that, was when I was talking about these worms, these little caterpillars. Let me see if I can find that clip here. Caterpillar and his, let's see, caterpillar, ladybug. Shit, I don't know what I did now. I probably should have queued up these videos before the thing. Yeah, I didn't plan. It's just it had been so long since I've been on stream, so I wanted to get out here, and I didn't really do that much planning here. So sorry about that. But I had a picture. I did a stream. You see, the last stream I did was that I found a caterpillar in my food. And I showed you a big tobacco caterpillar that I did find on my tomato plants. But there were also little caterpillars that I showed. What the fuck did I do with that, man? Yeah, let's see. What plant is this? Crows, gearing off on clouds. I've got all these things here. Caterpillar. That's not it. Caterpillar, donkey. Huh. Yeah, I don't know what I did with it. Oh, I know where I can find it. I can find it out on the web here. I can actually just look at my video and find it that way. Let's see here. All right. This will take me a second here just to bring this up. Sorry, if you're watching on the VOD, just fast forward this part until I get it figured out here. Browser window. I think that's what I want. Well, that's probably what I don't want. I don't know why that showed up really big there. Jesus Christ. Alright, we'll get it. Hang on, I got it. There we go. Okay. So this is on YouTube. Because I can't find my video. There it is. All right. I guess I can turn. They only eat nightshade stuff, nightshade plants. So I don't think it was on my kale. I think it must have been hiding somewhere in one of my tomatoes. I was very careful when I cut the tomatoes to make sure I didn't. Hang on just a second here. I looked and make sure. See if I can get this caterpillar up here. So you can look at a caterpillar that I had. Little baby caterpillars. Hey, look at that. There it is. Damn it! I found it. A few minutes yet. All right, I'm going to run this. I'll just run this video and I'll narrate it. Here's this little caterpillar. He's only about an inch or so long. I put him in a bottle, jar, and he climbed up to the lid, so he didn't want to be in there. But I took a little video of him here. So there he is. This is the guy that I found crawling on my kitchen sink, who evidently hitchhiked on. There we go. Okay. All right. So that little caterpillar there. When I was doing my last stream, and I showed it here, this stream, I said, "Oh, this little caterpillar is in on my tomato plant, and they start out really small, and then they grow up to that big caterpillar that I showed, that other one. And that isn't what it is at all. I screwed up big time. That little caterpillar, this little caterpillar here, is not even the same species as that big caterpillar that I showed. I didn't look the species up. I guess I could do that, maybe. That's something we could do, huh? Let me see if we can figure out what this species is. That would be a fun thing to do. Let me clip this. All right, can you see that? Oh, you can't see that. That's okay. All right, clip that. Then I'll save it. And then we'll go to one of these AI spots here. It's gonna ask me in my email, so I don't want to show that. Hang on just a second there. Add a file. Okay, there we go. All right, let's see if this is going to work here. Browser window. There we go. Okay. All right. So on this one, I told him my name was Art, because the first time I used this, I asked a question about art, so I used the word art. Okay, so it's saying what I uploaded this picture to it, so now I'll ask it what this is. What species of now I gotta spell caterpillar. God damn it, caterpillar is this? I found it on my... Where did I find it? I found it on my kale plants. Kale plant. All right, let's see what it says. Can you see that? Is that working? Yeah, you can read that, right? Yeah. All right, let's see here. Okay, great find. Yeah, the default mode on these AI things are sycophantic. They just, oh, you're great, you're just fantastic, you ask the best questions, blah blah blah. All right, so it says brachias, kale, cabbage, broccoli, etc. are magnets for a few very common caterpillars in North America. Based on your description and photo, here are likely suspects. Cabbage white butterfly. Smooth velvety green body. Yeah, that's what that is. Faint yellow lines down the back. Nope, didn't have that. Blends perfectly with kale leaves. Cabbage looper. Green, smooth, with faint white stripes. No, it's not smooth, it's velvety. It's got that velvety thing. Similar to this one, sometimes used interchangeably in garden guides. Imported cabbage worm. Close relative of cabbage white. Alright. Well, I guess we don't need to know, right? It's cabbage. Something cabbage. It's probably not this one. Cross-striped cabbage worm. It's not that. It doesn't have black and white stripes across it, so it's a cabbage worm or cabbage white butterfly. And I see these little white butterflies flying around all the time on around my garden all the time. So that's got to be what it is, right? Let's see what else it says here. How to narrow it down. I don't need to narrow it down. It doesn't matter, right? It's a cabbage worm. I'll just call it a cabbage worm. Hand picking is the simplest control if you only see a few. Check the undersides of leaves for bullet-shaped eggs, clusters. Yeah, I don't know. Encourage natural predation, like parasitic wasps and birds. Okay. Yeah, I do that. I kind of let stuff just grow in my garden. You know, I let like whatever plants want to grow, I let them grow unless they're really competing with my food plants, and that kind of helps get all kinds of different other insects and stuff growing, and it kind of keeps it in balance and stuff like that. So I had a really good kale crop, and damn, went out there this morning and all gone, all eaten up. The deer came by and just wiped me out. I can't believe just one deer. It must have been a family of deer that came and ate all my kale. So that kind of screwed me up. And anyway, the reason why I thought this little guy here, the reason why I thought he was the same one is because I thought he came off of my tomato, you know. All the big ones, those big giant ones, were on my tomato plant, and I had brought in a tomato and set it on the counter. And I also brought in the kale, and the kale looked completely clean. I didn't see anything on the kale at all. And I set the kale there too, and I washed the kale, did all that stuff. And then I saw this guy crawling there, and I thought, oh, he must have came off of the tomato, and he just hadn't grown up yet like the other tomato worms, you know. But no, he came off of the kale, and I didn't even spot him on the kale. So hopefully I didn't eat any of those guys when I prepared my kale. And I brought in some other kale the other day. Same thing. I took a whole bunch of leaves. Right, we were gonna have a frost, so I said, okay, I'll take off a bunch of leaves of the kale before the frost, just in case, you know. And so I did that, put them in a bag, and put them in the refrigerator for a week. And I pulled them out and was preparing them, and I had them sitting there. And then four of these caterpillars came out of my kale, just as it was sitting there on the counter. So I guess I had a whole bunch of those, and hopefully I got them all. Hopefully I spotted them, because they're like it says here, they disguise really well. Can you see that? It says a camouflage. Let's see, interchangeable. Yeah, magnets, very common caterpillar. Yeah. Movement style. If it arches its body and loops forward, it's a cabbage looper. Oh, I see. Okay. If it arches its body and loops forward, I don't know. Yeah. Yeah, they're just hard to spot. You know, I couldn't find them at all. But all my kale's gone now anyway. So, and it's down. Oh, it's not freezing yet, but it's only 10 o'clock and it's already below 2 degrees. So, oh, we got an ad going. So, talking about food. Keep eating, everybody. Keep eating food. Blah 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 blah. All right. All right, I'm gonna blow through that. I don't care. So that was another Corrigenda. I should say what the word Corrigenda means. It's plural for Corrigendum. Corrigendum is it's a really old word. Well, not that old. It goes back to like the beginning of printing. And it's been used for a long time in the book industry and the printing industry, publishing industry. When they print a book, you know, if they find a mistake in the book and they don't want to print the book again, or it's too late for them to fix it, then they print this other sheet of paper that lists. I'm sure you've seen this before. Maybe I'm sure you've probably seen this before. You get a book, and either bound in the book or just put in there, whatever. There's a thing that says, mistakes. Here are the mistakes in the book, typo here or whatever, and this word should be this word or whatever, and it has a list the page number and all that. So that's what a Corrigenda is it's a list of it's a page that lists the mistakes. So that's what I did today. I started my video and I said, okay, here are the mistakes that I made previous videos, and I'm gonna insert them into this video instead because I didn't know they were in the other videos. And I like to correct my mistakes. And please, please, if you see me make a mistake, type it into chat or type it into YouTube in the comment section. Because I like to get things right, you know. I think that's more important to get the information correct than to seem like you're correct. You know what I'm saying? A lot of people out there they'd like to try to keep this air that they're flawless or whatever, you know. I don't know, to improve their credibility or who knows. I don't know. I don't understand that shit. I got social dyslexia, right? I don't understand that. But they like to try to, you know, they don't like to say that they make mistakes. They don't like to, you know, maybe that's human nature. I don't know. But I like things to be right. So if I get something wrong, let me know. And, you know, somehow send me an email, type it in chat, type it in YouTube, anywhere. Anything that's wrong, anything that's not right. If I got a technical issue, if something's not right with my stream, if the audio's, you know, if I'm muted, whatever the thing is, if something's not right, let me know. Because I like to make it right. I like to say that I like the information to be correct. I like everything to be correct. And so, with that in mind, let's talk about gravity, because I'm gonna make a bunch of mistakes now. I want to talk about gravity and because gravity's cool. I think gravity is just the coolest thing. I think it's like the key to everything. So now we're talking about physics. Yeah, gravity. I wish they would teach gravity correctly at right from the start to kids, you know, because everything, you know, I hold a pen, right, and it's the weirdest thing. When I let go of this pen, instead of the pen staying right there, I let go of it, and it just damn thing just falls. You know, why does it do that? Why does it just? You know, I'm not I let go of it and it falls. Why does it do that? You know, it shouldn't do that. Yeah, it's because there's something going on, because this space around the pen, around the earth and everything is all curved. It's curved. The space is curved. So the pen thinks that it's just when I let go of the pen thinks that, okay, it's just sitting in one spot in space. But space and time are curved. Space-time is curved. So even though this pen, when I let go of it, is not moving, technically it's not moving. It's in space. It's not moving. When I let go of it, it's in an inertial frame. It's not moving when I let go of it. When I'm holding it now, it's being accelerated because it feels the force. Isn't that weird? When I let go of it, it's in an inertial frame. It's at rest when I let go of it. But because space-time is curved, it moves relative to us, because all of us are accelerating. If you take I was going to do a little experiment. I forgot to set that up. I don't think I have anything that will show that. But if you take like a little can or anything and tie it to a rope, you've probably seen this, right? You take a little something like, or you know, a bottle or something. Like if I have a bottle of water, and I tie a rope to this bottle of water and I spin it around. The water, instead of going like this, the water will still stay on the bottom. You know what I'm saying? It's almost like there's gravity, right? If you spin it around like that, there's a force. It seems like a force, an acceleration. And the weird thing about it is that, you know, normally when you accelerate, you know, if you're in a car or a bike or whatever you run or anything, when you accelerate, it's like usually just you're going one direction, right? And you say, okay, I'm accelerating, and this is the direction I'm accelerating. And I'm feeling the force in one direction, and that's how it works. But when you take like a can, like that experiment I just explained, and you spin the can or spin it whatever, the force is all over. It's not just in one direction. You know, it's the force is actually felt inward, centripetal, they say, and it's all over. You know, it's not like in one direction. And the Earth is kind of the same way. It's not the same force. It's not the same idea at all. But you know, it's like I'm being accelerated. You know, if I'm in New Hampshire, right? But if you're on the other side of the globe, you're being accelerated, which in what seems like the other direction, right? Because you're on the other side of the Earth, and that's kind of weird. How can everybody be accelerated? And how can we continually be accelerated? That's another weird thing, right? You think, well, if you're being accelerated, aren't you gonna, you know, run out of acceleration after a while, or whatever? But that's not how it works. It's like the can, right? If you're spinning the can, as long as you're spinning that can, it'll continue to feel acceleration, even though it's not moving, you know. If you're accelerating linearly, if you're accelerating in a particular direction, you have to keep going faster and faster and faster and faster and faster to keep feeling that acceleration. But the can, when you're spinning it, doesn't matter. It can just keep spinning at the same speed all the time, as long as you're spinning it, it'll feel that acceleration all the time. And same thing on Earth. We're sitting on the Earth. We feel this acceleration on our butts when we're sitting on the chair, and it's there all the time, and we don't have to keep going faster and faster and faster to feel that acceleration, but it's still there. The thing about gravity, it feels like it's a strong thing, you know. If you try to pick up, 100 pounds worth of something, a rock or whatever, it feels like a lot, right? It feels like a really strong force, but it's not. It's the weakest force. Compared to all the other forces, it's really, really weak. I can demonstrate that. Let me do it here. We can do an experiment really quick. Here, let me give you something to watch here. Let's see if I can find something here. Something that'll take a second to do. Where's my thing here? That's kind of weird. Oh, here we go. Okay. All right, hang on. I'll play this little thing for you. You can watch it. And then...
Sharing ideas with everyone. That's why copying is fun.
How was that? Was that entertaining enough for you to keep you busy while I was doing that? I know young people need to have stuff. They like to have they like to have something going all the time. All right, here. So this. All right, let's compare gravity to the electromagnetic force. Right? We got. They don't like to call them forces anymore. They like to call them interactions, which is more accurate. All right, but right there are four of them. Three of them that we know are really forces, and then gravity that doesn't fit in. One of these things doesn't belong. Right? Which of these things don't belong? It's gravity. Gravity doesn't belong. All right, let's see. Will this work? Yeah, this will work. All right. So, all right, paper clips. Paperclip apocalypse. This is a paperclip. It's different than the other ones, but it'll still work. All right, so I hold this in my hand. This is a paperclip, and it has a force, right? Oh, you know what? I didn't. Let me put my. Shit. Where'd my ad manager go? There it is. Okay. I want to put my little ad manager down in the bottom there so we can see it. And I'll know when the ads are coming, hopefully. All right, so this is a paper clip, right? I let go of the paper clip, it falls, all right? And it falls until it hits my hand. And when it hits my hand, there's an electromagnetic force that stops this. You see, there's no electricity. Why is that? The molecules in my hand and the atoms in my hand have electrons around them, near them, kind of. And so does this paper clip. This paper clip has electrons in its atoms. Electrons have a negative charge, and particles that have the same charge repel each other. That's basic stuff, right? So when I put this paper clip on my hand, the electrons in the paper clip are repelled by the electrons in my hand. And it won't go any further, right? That's why it doesn't go through my hand, because the electrons get in the way. They push you against each other. That's why it stops. But the curvature of space-time causes this thing to want to go down, from our perspective, from our point of view, from our reference frame. It wants to go down, but it stops due to this the electrons in there. So there's a force, right? Or what seems like a force to us is that it's gravity, right? Is pulling down on this thing, right? To make it want to go down. But gravity is really weak, and you say, well, yeah, maybe for this little paper clip, but if this was really heavy and blah 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 blah, right? But let's compare the force of gravity to the electromagnetic force. All right, you got this paper clip, and you have the Earth, right? The Earth versus paper clip. All right, so you got the big huge Earth that we're on, and all of that Earth, the force that all that Earth summons pulls the paper clip down. Now I got 3 little magnets here. These are refrigerator magnets, probably the weakest magnet you could ever find. These are cheapo little things, right? So let's see which is stronger, this little magnet or Earth. Okay, let's see who wins the tug of war here. Yeah, the stupid little refrigerator magnets are stronger than Earth. See? The refrigerator magnets are able to pull the paper clip up more strongly than the entire Earth is able to pull the paper clips down by curved space-time. That's why they say that the gravity is so weak. It's because because even with the whole Earth pulling on stuff, electromagnetic stuff like this, or the electrons the little electrons in the atoms in my hand, and can stop the paper clip. That's why they say that the gravity is a weak force, quote unquote force. And it's not really, they say it's force, and then they say, well, gravity's not a force, blah blah blah. It's a curvature of space-time. So everything, as far as we know, everything that moves through space follows the curved path of space because of gravity, which means that everything is affected by gravity. Not just matter, not just things that have weight or have mass, or everything. Light is curved by gravity. Everything, as far as we know, is curved from gravity, because gravity curves space-time. And there's some experiments that they're working on. One of them is really cool because we've tested gravity with matter and with light. All these things we see it. We've observed it. We tested it experimentally. We look out in the cosmos. We see this happening. That the curvature of space-time causes things to curve or to fall or whatever. But there was let me see if I can find this here. There was a they did an experiment. Here it's right here. All right, what is it? All right, we got that. I'm going to pull this paper up and we can look at this paper. Document window, is that what that is? Sorry, I'm messing around with this here. Just take me a second to get this whole thing. Just a second. Okay, there we go. All right. So this is a paper, a test, an experiment that they did. All right, we got a goddamn ad here. Hang on. That's okay. I'm gonna blow through this ad. It doesn't matter. Make sure we're all right here. All right. Yeah, I'm just gonna blow through the ad. Doesn't matter. So this is an experiment that they did, and it's the observation of the effect of gravity on the motion of antimatter. So you get what happened here. We've observed all this stuff. We've observed matter, energy, light, all types of light, X-rays, infrared, radio signals, everything curves or falls due to gravity, right? Whereas the other forces work with themselves, or like electromagnetic force, right, is only attracted, like an electron is only repelled to another electron or attracted to a proton, something of an opposite charge it's attracted to, same charge it's repelled from. But like a neutron, something with a neutral charge, it doesn't affect it, right? But gravity affects everything because it curves space-time. And anything that moves through space-time, as far as we know so far, is affected, follows that curvature of space-time, or falls, right? Falls if you're on the surface of a planet like Earth, it falls, right? You let go, it falls, right? But something that we had not tested and we weren't sure about was antimatter. So they did this cool experiment recently, a couple years ago. Antimatter is matter that has the opposite charge. So if you have like an electron, an anti-electron, otherwise known as a positron, has a positive charge rather than a negative charge, right? Electron has a negative charge. Antimatter electron has a positive charge. Same with the quarks. If a quark has a positive charge to it, the antimatter particle of that quark would have a negative charge, or vice versa, or whatever, right? So that's the difference between matter and antimatter. And you've probably heard, right? Antimatter. If you watch Star Trek, right? You heard, antimatter explosion, boom, bigger than anything, right? And it's true, but you need a lot of it. You need a lot of antimatter to make a big explosion, for that to happen. And it's hard to make antimatter, so they have to make antimatter. They have to bump particles together and watch them decay, or you can wait for that's true. There's positrons are made in normal radioactive decay. That happens too, but it's tiny amounts. And they, of course, as soon as, like when something decays and produces a positron, positron's gonna bump into something else, all right, and it'll go away. So it's hard to make antimatter and contain it and keep it, right? And so they've known about antimatter for a long time, right? I don't know how long ago, was it 70 years ago or something like that, or was it Dirac who said, hey, this math says there might be this other little thing, and sometimes math does that. There's certain stuff in math where it'll come out with you get two, like the quadratic equation, you get a positive and a negative, and well, which is it? Well, there's only one that makes sense in the real world, right? In the math, there are two things that two answers you come up with, but only one of them makes sense in the real world. And it was like that with what they thought with matter. They kept doing these, they figured out all the math, and they said, okay, here's the electron, but there's this other thing that has a positive charge, but all we see is the electron, so it must be a math thing. And in this other, I think it was Dirac who said, no, these are real things, And they eventually found it, and with their experiments and stuff, and they found a positron and said, oh yeah, it's a real thing. We'll call it antimatter, right? And so this antimatter, they know about it, but it's hard to work with, because as soon as it comes in contact with regular matter, it annihilates, right? They annihilate each other and turn into energy, turn into photons. So it's kind of hard to work with. It's hard for them to make these antimatter things and particles and contain them and work with them and all that. So it took many, many, many decades until they finally got to the point where these guys here, Anderson, Baker, and all these, look at this big bunch of these people here who all wanted their name on this paper. They finally figured out how to do this test with antimatter to see if it actually is affected by gravity or not. Because they couldn't tell, right? There was no way they could get enough antimatter, and also when they get the antimatter, because it's charged, right? It's just like regular matter. It has a charge on it. It's going to be attracted or repelled by other matter. It's kind of hard, and the gravity is really, really weak, like I just demonstrated, right? It's many orders of magnitude less force for gravity than for electromagnetic force. So it was hard for them to test this thing, to see if the antimatter is actually affected by gravity. And the way you would do it, right, is you would make you'd make a particle of antimatter and let it go and see what it does. Right? If it falls down, then it's affected by gravity, right? Makes sense. The problem is that a tiny little particle like that, and you make it, and you gotta put magnets and shit on it to keep it from bumping into things. So it was hard for them to measure. So what they finally figured out what to do was, instead of just making an anti-electron or an anti-proton, they made an anti-electron and an anti-proton, and put them together and made an anti-hydrogen. Right? You got a proton and an electron. That's hydrogen. So, but they made them out of antimatter. So you got anti-hydrogen. And the cool thing about that is it's neutral. It's a neutral charge, because you got a plus and a minus, right? You get the electron and positive and the proton. That makes a neutral charge antimatter. So that's cool. But that's real hard to do, right? It's you gotta collide things, you gotta do shit, you gotta produce the electrons, you gotta produce the protons, you gotta produce enough of them, and put them together in a way so that they're not bumping into other stuff, and it's hard to do. It's technically it's a hard thing to do for an experiment. But they finally they said, okay, they figured out how to make antimatter hydrogen. And they've been working on this for years and years and years. And they said, okay, let's see if this antimatter hydrogen now that is not going to react with all this other stuff in our apparatus and our equipment and all that, because it's neutrally charged. We'll look at that and see if it falls in gravity. And of course, it has to be in a vacuum, of course, and so it's not bumping into air molecule into the whole thing, right? And so they tested it, and they finally got it figured out. And and this they call it the weak equivalence principle. Remember when Neil Armstrong went on the moon and he dropped the feather in the rock, or the feather and the hammer, right? And they fell at the same time. Same experiment that Galileo did. Said he did. We don't know if he did it for sure. Drop two things at different weight, but everything falls at the same speed. That's called the weak equivalence principle in gravity. It means that everything falls at the same rate. And the reason why everything falls at the same rate is because it's not really a force. Everything is just going through space. If everything's just sitting in space and time, and space-time is curved, then everything will move at the same rate, right? All right, let me see if I can get this thing to. Okay, so this is the paper they did. Observation of the effect of gravity on the motion of antimatter, and weak equivalent principle just means they tested to make sure that it would fall like anything else, right? Like the hammer or the feather or anything else. They wanted to see if these if antimatter would do that, anti-hydrogen. And they had this set up here. This is highly technical thing. This is actually a small thing because it's small stuff, right? These are little teeny particles. It looks like a big thing here, but it's a tiny. This is just like a few millimeters or something, or 3 meters. There we go, 3 meters. But the inside of it is really small, and what they did is they shot in the electrons and the protons, anti-electrons and anti-protons, and got them together and made this anti-hydrogen. And they have to shoot a whole bunch of them too, right? You got anti-protons coming in one direction and anti-electrons coming in the positron is the same thing as an anti-electron, same word, same deal. And they shoot them in, make this anti-hydrogen, and then they have to use all these magnets and stuff to contain it and make sure it's all, how they can capture it and hold on to it. And they have to make a whole bunch of them. And then they just what they do is they apply magnetic fields to it. Even though it's a neutral thing, they can move it around still with magnetic fields. But they can trap it. Time projection too. Look at all this stuff. They got all these different solenoids, and experimental physics is just amazing what they can do. A 3T solenoid magnet, not shown. So what they did is they put it in there, and they would manipulate them, right? They put these different fields on and shit, and try to make them go up or down or whatever. And they could tell that once they got the whole thing done, they got a chart in here. Here, I'll show you this chart here. Once they did the whole thing, then they mapped it all out, and they tried they put a force up on it, a positive force, and a negative force, like equivalent to a gravitational force, 10g, a minus 10g, or a plus 10g force, not with gravity but with magnets, an equivalent force. Anyway, they did that, and they tested them all, hundreds of these anti-hydrogen atoms, and looked at them and see where they, how far they, if they would fall up or fall down, and how fast and how many of them would make it how far down the chamber before they bumped into their sensors and all that kind of stuff. And they figured out the statistics on it and did the whole thing. And what they found was that, here's the actual data, right? And see, it's going down more than it's going up, So, and they figured out a chart on it, and they figured out what it would be like if it they said, okay, if it was just ordinary matter, it would follow one path, and then if another thing they tested for is they wanted to test, because there are a lot of people out there were saying, oh, well, antimatter has anti-gravity, right? That was the thing. There was no reason for them to say it, but people were saying it. And so they tested for that. They said, okay, let's see if it falls up, right? If you put these antimatter into this thing, chamber in a controlled thing, if there's anti-gravity, which maybe, who it could have, then maybe they fall up instead of fall down. But they fell down. So they figured it out, but one of the things that they figured out here in the conclusion was that the force down was 0.75 g instead of 1 g, which right, that's different, right? If you just let something fall or measure the force, it's going to be 1 g, right? G of force, like a 9.82 meters per second squared. What's 1 g? That's what they would expect, but they got 0.75 instead. So that was different. I think that's within their. It says, consequently, we can rule out the existence of a repulsive gravity of magnitude between of 1 g, right? So there's no anti-gravity. They ruled that out. The results are thus far in conformity with the predictions of general relativity. Okay, so they're saying it looks like it's following. It's following the curvature of space-time, just like everything else, except that they've got some error here, right? They've got 0.75 instead of 0.1, and I think down here they say, okay, future experiments we should get that dialed in a little bit better. So that was cool. So that's kind of like breaking or cutting edge stuff that they're doing tests with gravity. Now, what they didn't do, and I haven't seen anybody propose this. Oh shit, we've got an ad here again. Oh, that's okay. I'm gonna blow through the ads. I don't care about the ads. So what they haven't tested, and I haven't seen anybody propose it yet, but I'm sure somebody must have proposed this at some point, is to actually test the antimatter to see if there is curvature of space-time around the antimatter in the way that there is around ordinary matter. The Earth, right? Earth is matter. Anything that has matter or energy, matter and energy is the same thing, right? E equals mc squared. Anything that has energy or matter has a curvature of space-time associated with it. That's what Einstein's field equations are for general relativity, is they explain that correlation between matter and or energy, the energy tensor, stress tensor, the stress energy tensor, and space-time, the curvature of space-time. That's what those equations do. The equations of general relativity correlate those two things. But it's hard to measure gravity on really small things, right? One of the tests, and I didn't look this, I should have looked this up and found a link somewhere to this thing, but they're trying to do tests where they can take really, really small masses and measure the gravity basically measuring the curvature of space-time around those small masses, measure the gravity. There's a guy called Cavendish who did this experiment you may have heard of, where he took weights, like 10 kilograms or something of weights, and put them on a torsion apparatus and brought masses next to it and actually measured gravity, because gravity is such a weak force, and it was quite an experiment to get that measured. But this was 100 years ago, more than 100 years ago, that he did that, and he actually measured gravity, and that's where they came up with the big G, the gravitational constant. They found out what the big G number was. But that's kind of hard to do with small masses, And I don't know what they've gotten down to now. The amount of mass, it's less than grams, I think now. I think it's micrograms or milligrams or something that they've gotten down to now. And the important thing about that, why that's important, is to be able to measure the gravity of tiny things. Is they're trying to, the math, doesn't resolve in between general relativity and quantum mechanics. When you get really small bits of matter, it doesn't match up, because quantum mechanics says it's probabilistic. There's no, and it's quantized and stuff, and things can be in superposition, and general relativity doesn't allow for that. It's not set up for that. So they want to try to resolve that and figure out which one's right. Is general relativity right? Is it continuous all the way down? And do Einstein's equations hold up, or does it do something else? That's this whole area of quantum gravity. That's what everybody's trying to figure out. And so one of the ways they can do that, rather than just doing thought experiments and just doing a bunch of math, without really having any data behind it, is to do some experiments where they actually take really small amounts of matter, tiny amounts that are so small that they can put them into superposition without them decohering, and yet still be able to measure gravity on it. And that's the next challenge. So that's the next thing they want to do, is to try to take small amounts of matter and put them into a location superposition, so that they're actually, it's not just like a spin superposition, but it's actual location. And they've been able to do this with not just single particles, but like masses, groups, atoms or whatever, and put them into a superposition of some measurable distance, So once they've also built these tiny little essentially Cavendish torsion measurement things, not physically, but using fields, magnetic fields, and the other stuff, and so they can measure small amounts of gravity. And once they get those two things to cross, once they get the mass, the amount of mass that they can put into superposition high enough, and the amount of matter that they can measure gravity on low enough, and they cross, and they can get a mass that's small enough that they can put into superposition, but large enough that they can measure gravity on. Once they get to that point, and they actually work out all the technical stuff, then we're going to learn something. we're going to learn what happens to gravity. Does the gravity go into superposition too, or is there only half, or what happens? So they want to figure that out. So that should be pretty cool. And one of the things I've talked about this before, this experiment here with this antimatter was testing the weak equivalence principle. There's another equivalence principle that Einstein proposed, which is the equivalence of acceleration that you would feel, like say in a rocket or whatever, feels equivalent to the acceleration that we feel on the Earth. And that's how I actually developed general relativity. Let me see if I can find that here. I don't need that anymore. Let's see here. I'm going to see if I can find these little equivalence principle. There it is. Okay. Okay. Let me see if I can pop this up here. Just take a second. I'm sorry, it takes a second for this to work. There we go. So, okay, so we were just talking about what they call the weak equivalence principle. This thing, remember this thing, right?
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Okay. All right, so that's the weak. That's called what they call the weak equivalence principle. That everything falls at the same rate, and we can try that right now. This is actually kind of cool. I found some feathers. Here's some feathers that I found out. These are turkey feathers. Which I'll explain later why I found these in the yard, but I found some turkey feathers out there, and I've got a hammer here. Hang on just a second. There we go. So I can do this test right now here, and we can test this, right? So I've got a feather and a hammer, and we'll test it. I'll drop the hammer and the feather, and we'll see if they fall at the same time. Ready? Oh shit! Okay. All right. All right. See, the feather took longer to go down. Did you see that? So what can we conclude about that? Actually, they hit about the same time. But the feather, right? It floats down, right? Instead of. And for thousands of years, they thought that heavier objects fell faster than lighter objects. But it's just air resistance, right? It's feathers, feathers. It's the air, right? That's why there's a difference. That's the weak equivalence principle. But there's another thing. This thing here is the. This is the. This is the what do they call this? Just the equivalent, the general. What do they call the strong? Let's see if they call this here. Weak form, extended form. They call it the extended form. I don't know. It has nothing to do with the other thing. I don't understand why they call it the extended form. But anyway, right, in this one they've got, if somebody is inside a rocket ship that's accelerating, right, it's being pushed, and it's being accelerated at 9.82 meters per second squared, it'll feel like in this rocket that there's gravity, right, because it's being accelerated. And the idea is that it's equivalent to being in a rocket or a room, whatever, on the Earth. It's the same thing. And it's not exactly equivalent because on the Earth, the further you get away from the Earth, the less the gravity is. So the gravity at the ceiling here is less than the gravity at the floor. So there is a difference. It's not exactly equivalent, right? On this rocket ship, the gravity here at the floor is going to be the simulated gravity on the floor is going to be the same as what it is at the ceiling. It's all going to be even. It's linear. It's the same throughout the whole thing. Whereas on the Earth, it's different. It's stronger on the floor than it is on the ceiling. So there's a difference. That's why when they talk about the equivalence principle, they say local. It's at a local spot. It has to be at a point or a local point. It's equivalent. Okay. So if you have two different points, or if you have a space, a volume, then it's not equivalent, because it's going to be different in a gravitational field, like on the surface of the Earth, stronger on the floor than it is on the ceiling. If you're in a rocket or something that's accelerating, it's going to be the same acceleration on the floor as it is on the ceiling. It's going to be the same. So the only way to say that it's equivalent is to pick a point somewhere. Point on the floor, on the ceiling, whatever. Find a point that's equivalent to two things, and make them equal, so that you're accelerating at the right speed that makes it the same acceleration as if you were on the Earth. I'm not explaining this too well, God damn it. So this ball, right? This point where this ball is, okay? Let's say this spaceship is accelerating at 9.82 exactly meters per second squared. And let's say you're at a location on Earth where this ball at this location is exactly 9.82 meters per second squared. But if this ball was higher up, it'd be, 9.819997 meters per second squared or whatever, right? It'd be a little bit different. But at a particular point, it's going to be the same the same acceleration. Okay. The problem is that when you get because it's a point, theoretically, if you, there's going to be, does it quantize at some point? That's the thing. Is it continuous? Relativity is set up so that everything is continuous. That there is nothing is quantized. But when you get down to smaller and smaller and smaller and smaller points, pretty soon you're going to have, the space between atoms or whatever, or even smaller within the nucleus of an atom. Within a proton or whatever. There's going to be different points. And on Earth, that difference, in theory, would be measurable, right? We don't have anything that could measure that. We probably won't for a long, long time. But in theory, those 2 points are going to be different because they're in different points in space, different radius from the Earth, center of the mass of the Earth. So they're going to be different, and they'll have different gravity. Whereas in an accelerated rocket like this, the two different points across the proton, like if this was a proton, protons aren't balls, by the way, but if it was, then it would be the same. So that's kind of a thing, right? That's tension, they call it. There's a difference between those two theories. That's just one of the things that demonstrates it. So if they can, so the idea is if they can get matter small enough that they can get it to go into superposition and then measure gravity, that they could learn about that. Whether gravity actually quantizes when it gets down really small like that or not, or whether it keeps on being continuous. So that's kind of an interesting thing about gravity that we don't know yet. What else was there? There's some other stuff about gravity that I want to talk about. Let's see. I've talked in previous streams. I've already talked about stuff that orbits the Earth and that's relativity more than gravity, I guess. And I talked about on the twin paradox and how when something accelerates and turns around, how that kind of gets related to general relativity. There was something I was watching this Star Trek. Are you familiar with this series called Star Trek Continues? It's a fan production of Star Trek. It's not an official thing. It's like a pirate or whatever they call it, fan fiction. It's fan produced thing. It's actually really good. You should look it up. Star Trek Continues. Anyway, I was watching that today, in fact, and they had this. One of the episodes was about black holes, and they were showing somebody falling into a black hole, and they screwed it up. They showed it. I should have gotten a clip for you. Maybe I'll do that sometime. Show you this clip from this thing. They screwed it up because they showed somebody falling into a black hole, and it was like you see this trope where somebody falls into a thing of lava and they turn into fire or whatever, That's what it looked. That's what they showed it as. They showed this spaceship falling into a black hole, and it got down into the black hole, and then it flashed and turned into a big bright flash, like it was disappearing or something. And that's not how it works, because when something falls into a black hole, couple things happen. One, time is going to slow down for that thing, for that observer in that reference frame, from our perspective. So if you see somebody falling into a black hole, they're going to fall. And if you can see them, all right, we'll get to that in just a second. But if you could see them, they would appear to start slowing down and slowing down, as they get to the event horizon or whatever, and just stop before they actually went in. From our perspective, that's how it would look. If we were on the outside of the black hole, seeing somebody falling into the black hole, they would just start to fall and slow down, and then they'd just freeze right there at the event or near the event horizon. So that's one thing that would happen. That's kind of weird. So really, nothing ever actually falls into a black hole. Because it never gets there. It asymptotically approaches the event horizon, but never actually gets to it because of time dilation. They keep slowing down. From their perspective, it feels like they continue to fall, but from their perspective, they continue to fall forever. And everything, the rest of the universe, goes through the whole age of the universe, passes by for them as they're still falling. It's kind of weird. But the other thing that happens when something is falling into a black hole like that, because their time slows down, because they're slowing down in time, everything slows down, including all the everything that makes the light that they are emitting slows down too. Not the light itself, but the clock that is making the waves that make the light. Right? Light is a wave, right? And visible light is at a certain wavelength, and shorter wavelengths make light that we can't see, that's like ultraviolet and X-rays and gamma rays, get shorter and shorter, tiny wavelengths. And then things that get longer wavelengths are like infrared and microwave, and then radio waves, and they get miles and miles and miles long, the wavelengths of electromagnetic radiation of light. Right? Physicists call it light. No matter whether you can see it or not, they still call it light. So what happens is when this person or spaceship or whatever is falling into this black hole, things go slower and slower and slower for them, which means that the light that they emit is getting longer and longer wavelength. It gets red shifted, right? Lower, right? Longer, slower, lower frequency, longer wavelength light is red shifted, they call it, and higher frequency is blue shifted, shorter wavelengths. So as something falls into a black hole, it gets redder and redder and redder, and it gets red shifted as it's falling in, from our perspective, watching it. So what would you actually see for something falling into a black hole is it would actually turn redder. It would shift redder and redder and redder and redder. It would look like this. Here, I'll show you. We'll do a demonstration here. We'd start doing this. We'd start going like this. Is that working? No, that's blue. So there's blue shifted, right? It would whatever it is, it would start going redder and redder and redder, and it would turn like this, right? That's what it would start looking like. Oh, no, I forgot what my setting was at. Right, there we go. So it would keep shifting, keep getting redder and redder and redder until it got into infrared, and then you couldn't see it anymore. You know, it would be like if you take like a piece of metal and heat it up until it gets white hot. You ever see that before? I'm sure you've seen that before, right? Blacksmiths and all that stuff. You get a piece of metal white hot, and then you take it out of the heat and you watch it, and it slowly it turns from white to yellow, and then to red, and then the red gets dimmer and dimmer and dimmer and dimmer, and after a while you can't see the light being emitted at all. That's what it would look like but it wouldn't just be the black body radiation. It would be all radiation, everything that gets radiated from it. So it would get redder and redder and redder and redder until it shifted into infrared. You wouldn't see it anymore unless you had, night vision glasses or something. And it would continue to shift, and it would go into radio wave emission, and then it would go, longer and longer and longer radio wave emission until the light itself would just the wavelength would be longer than presumably the length of the universe, right? I mean, it would keep going, right? That's why we see when we look at you've heard of the microwave background radiation. That's why it's microwave. It's because it's been redshifted, not because it's fallen into a black hole probably, but because the universe is expanding. There's actually a theory that the expansion of the universe is not due to the expansion, but it's due to us being in a black hole, because it's a similar effect, right? I just explained that effect, that things are redshifted the longer it falls in. Some people, because of that, propose that this expansion that we see in the universe is because we are in a black hole, and we are experiencing that red shift because we're falling into a black hole, or we are in a black hole. But anyway, that's how the red shift works, and this microwave background radiation, cosmic microwave background, CMB they call it. Let me type that into my Wikipedia here. Cosmic microwave background. Does that show up? Okay. All right, so it's showing where the frequency that it peaks at here. And what is that? 6 millimeters? Is that right? Or centimeters? I don't know what it is. I wanted to see if I could find in here the actual wavelength that it was when it was created. I think it's close to X-ray, but I'm not sure, and I wanted to look that up. History? No. Here's theoretical models. Let's see. See, the idea is that during the Big Bang, right, a lot of stuff happened, a lot of heat was made, a lot of light was made. And at some point, the light was able to escape at some point during the Big Bang. And at that point, whatever temperature, there it is, 3000 K, there it is, okay. Okay, as the universe expanded, I don't know what that word is. I don't know how to pronounce that word. Yeah, I don't know how to pronounce that word. Caused the energy density of the plasma to decrease until it became favorable for electrons to combine with protons, forming hydrogen atoms. Okay, so yeah, they're saying the current theory is that when the universe was formed, all the matter was packed into a small singularity, and then for unknown reasons it decided to blow up, or it decided to expand, and and as it expanded, because everything was in a small area, that's a lot of energy. It's the highest or the lowest entropy that we know of. Is that the Big Bang? The theory says, and that all this matter was already there, and it expanded, and because of all the energy, there was so much energy that it was a plasma, meaning that nothing could. The fundamental particles couldn't come together to make matter, but at some point it was able to do that, and eventually it made protons, and then the protons combined with electrons to make hydrogen atoms. And they're saying that it says this recombination. Can you read that? Is that big enough to see? This recombination event happened when the temperature was around 3,000 Kelvin, or when the universe was approximately 379,000 years old. As photons did not interact with these electrically natural atoms, the photons began to travel freely through space. So there was a point, they're thinking that at this point in the formation of the universe, that that's when the light began to be able to escape. And they're saying it was at this temperature. So that's visible, right? That's visible, like 3,000 K. You can see that. Right? That's the light bulbs that we have in our homes and stuff. So that's normal color temperature. It says the color temperature of the ensemble of decoupled photons has continued to diminish. So it started as visible light at 3,000 K, and it's dropped and gone longer and longer wavelengths. And now they're saying it's at 2.726 K, which is what microwaves are at, because of the expansion of space, because the universe keeps expanding. So that's kind of cool. So anyway, that's what would happen with somebody who fell, or anything that falls into a black hole. It continues to shift like that, in its temperature like that. So if you ever see on Star Trek or anything else, if they show somebody falling into a black hole and it flashes or blows up or whatever, that's wrong. It would just get redder and redder and redder until it disappeared, because it turned infrared. You know, that's what it would actually look like as it fell into a black hole. So that's how black holes work. Yeah, black holes. I talked about that a little bit before. There's so many weird things about black holes, and things that people don't understand about black holes. You know, they talk about singularities, and everybody thinks, oh, singularity is at the center of the black hole. That there's a singularity at the center, because they think that everything in a black hole has crushed down to an infinitesimal point. And that's what the singularity is in a black hole, and that's not what it is. It's when the black hole forms, when any planet, even before it becomes a black hole, any planet has a gradient of gravitational force. Like on the surface of the Earth, right? We have a certain 9.82 meters per second squared, and the further radius you get away from the Earth, the lower the gravity goes. Well, as you go down into the Earth, it gets higher and it gets higher. But that only happens to a point, because after a certain amount of time, you've got more and more mass behind you as you dig in a hole, right? And it turns out if you dig a hole all the way to the center of the Earth, there's zero gravity in the center of the Earth. And it's like that. It's like that for any planet. Any planet is like that. If you go to the center of it, it's got zero gravity at the center. And depending upon the composition and density and all that, or what the material that the thing is made out of, it'll have a certain gravity at the surface, and it will increase as you go lower and lower. But then there's a point where it reaches a maximum, and then as you continue to drill down into the planet, the gravity gets less and less and less and less, because you're getting more mass, closer to the center. And then when you get to the center, it's zero. And it's like that for black holes too. The gravity at the center of a black hole is zero, which is just mind-boggling, right? People think, oh no, if you go to the center of the black hole, then gravity is infinite or whatever, but it's not. It's not. That's not where the singularity is. If there is a singularity at all, it's at the event horizon, because that's where the maximum gravity would be. That's where the maximum time dilation is going to be. That's where things stop. That's where time stops. So that's if you want to call it a singularity, that's where it happens. But at the center, it is zero. There's zero gravity at the center of a black hole, because it's the same mass all the way around. There's something called the shell theorem that talks about if you have a shell, or if you take a planet and you hollow out a center part inside of it, any place inside a hollowed out center inside of a planet is going to be zero G, zero gravity, and you would just float. So like if you took the Earth and we took the core of the Earth out and had this big gigantic hollow part in the center of the Earth, every spot in that hollowed out center would have zero gravity. You could just float anywhere inside there. And it's like that. That's called the shell theorem. And because of that, the center of planets have zero gravity. But there's like, that's theory, right? But if the density is different and all that kind of stuff, you're going to have different forces. And in a black hole, that'll probably be the case, right? There would be, there's stuff going on, right? It's spinning, and it's got different densities and all kinds of stuff. So it's not going to be exactly that way. But that's not where the singularity is. It's not like the whole thing crushes down to a single point and there's a singularity. That's not what happens. There's an event horizon where time stops, and that's it. And you might have stuff happening inside the black hole, because as I said, the further you go down, the closer you get in radius, the higher the gravity. But once you get past a certain point, then it starts getting lower again, and that would be the same thing, the same idea. There would be the event horizon is the point where time stops, where the gravity would be the most, maybe infinite. Who knows? I don't know. They don't know. the math breaks down. But inside the black hole, presumably then the gravity would be less, which would mean there would be time would happen again. Things would happen again, right? It wouldn't be time wouldn't be frozen on the inside, maybe. And then who knows what's going on, right? is the inside of the black hole, is matter inside there being attracted to the more higher level of gravity at the event horizon? Is it does it collapse again into another black hole in inside, and then you've got a the Russian doll thing where you got the layers and layers and layers of black holes? I don't know. It actually works out differently because when you're working with a black hole, because of relativity, general relativity, the math works out differently than with stuff that is not so strong that general relativity comes into effect. So it is different, and that's way above my pay grade. I don't know how that works. I don't know how they figure that stuff out. There's a guy named Kerr. What's his name? Richard Kerr, Donald Kerr. I forget the guy's name. He called the Kerr metric. He's one of the. He figured out the math for a rotating black hole, which was quite an accomplishment apparently. So, and they've got all different ones. Schwarzschild did the first one right after Einstein figured out general relativity, just within a couple years or something. Schwarzschild figured out that hey, if the mass is big enough, you got infinities and all this, and they didn't know what to think about that in Einstein's time, and Einstein rejected that. He said, no way, now you can't have infinities, you can't have black holes, there must be something that would stop that, But then later, it got confirmed, right? We've seen it. We've got all kinds of evidence now for black holes. Presumably they've seen them. I'm not buying that, but certainly the light, the gravitational waves they've measured and all that. So they know that they really exist. Neutron stars and black holes and all that. So. Anyway, so it was shortly after general relativity that Schwarzschild figured out the equation for what they call it the Schwarzschild radius, the radius at which the mass is so high and the gravitational or the curvature of space-time is so much that light can't escape. And they call it the event horizon, and presumably that's where time stops too, or approaches. It doesn't actually stop, but approaches zero forever, or whatever, however you want to figure it out. So yeah, a lot of stuff on gravity. What else is there? There's something else I want to talk about on gravity. I forget what it was, but let's see. I don't think there's anything else on the CMD here. You can look at this here. Yeah, there's all kinds of stuff here. Barometer. All right. I guess that's enough for gravity. I got my invite code finally. I went to Reddit or somewhere and I found somebody who posted an invite code and it worked. I had been trying this over and over and over again. I didn't know anybody who had Sora. Back up a little bit. OpenAI company does these large language models And one of the things that they figured out they could do with this stuff is make images, produce images by through a process where they put in noise and then they take everything away that they think is not what the transformer is asking for. And anyway, once they figured out how to do images, then they figured out they could do an image and then make the next image and the next image from that, using the same process with these transformers and stuff. And so they make videos now. You can go to they call it Sora, Sora, and now it's Sora 2. They've got a new version of it. And you can go there and type in a prompt just like you would. I'm sure you've all used these chat GTP and all that, right? Where you type in a prompt, but instead of the thing answering, you type in a prompt, and instead of the thing answering with a text output, it makes a video. So you can say, please make me a video that does blah blah blah, whatever. And I did that. I did that with you saw it here, right? When I did this this thing here, right?
Oh, hi. This is the Double Tribble channel. My name is Ron, and I live in rural New Hampshire, surrounded by forests and wild animals. Wait, I'm still a cartoon. Hold on.
Yes, so you see how that was all I typed into Sora. I said, it has a little facility there where you can upload an image and tell it to make a video based on the image, and that's what I did. I uploaded this cartoon picture that I had, which was made by another AI thing somewhere. I took a picture of myself and uploaded it to this other service. What do they call it? Gibby, I forget the name of it. And that would make a cartoon out of you. So I took my own picture of me from one of my streams with these headphones and all that. I uploaded it and said, please, make a cartoon of that. And it made that cartoon. And now here, 6 months later, they come out with this Sora. And so I take that image, that cartoon image, upload that to Sora, and said, Sora, make this cartoon image talk and move and talk and say these things, and it did it, and all I had to do was type in those words for it to say, and it made that video. It's really astounding. It just blows me away how they're able to do all that stuff. So I made some videos here. Let's see here if I could find one here. Okay, here's one that I did. It's probably actually easier for me just to go to YouTube here and play them. Let me do that, Kate. Let's see if I can find this here. Here we go. Okay. All right. I'm going to see if I can get this onto the window here, onto the screen. Do I have any ads coming up? I think I've got some time here before the ads come up. All right. Here we go. So here are a couple videos that I did. I've got an account out on YouTube called KXQE, which is a different account from my where I put my VODs, my Twitch VODs, but it's another account up there. So I just loaded these up today, or was it yesterday? I forget. Yeah, today. And I made this one called Maximize Paper Clips. There's a thing out on that I'm sure you've heard of before called the Apocalypse, the AI Apocalypse. The idea is that one of the things with AI is they say, oh, it's not going to be aligned with our interest, or it's so smart that it's stupid, or whatever. I mean, and the example that they use is, somebody thinks that they want, somebody, a paperclip manufacturer somewhere wants to make paper clips very efficiently. They want to maximize their production of paper clips. So they type into an AI, maximize paperclip production, and then the AI goes crazy and ends up turning everything in the whole earth into paper clips because it's trying to make more paper clips, right? They call that the paperclip apocalypse. So what I did is I took that and I had some fun with it and made some funny video out of it. So here, I'll play this one here. I don't know if it's going to work or not, but we'll try playing it here and see.
All right, AI, let's do this. Maximize paper clips.
Understood. Maximize paper cuts. Initiating now.
Wait, what? No!
All right, so that was my video about maximizing paper clips, and the idea was, of course, that the AI thinks clip, right? Like cut. so instead of maximizing paper clips, it maximizes paper cuts. So that was episode 1, and here's the season finale. Oh shit! That didn't work. That just showed me. Sorry. Hang on just a second here. All right, I'll try harder. All right. Here's the season finale. All right, so that was the. Let me see here. All right, maybe I need to make this go to another screen here. Here we go. All right.
All right, AI, let's do this. Maximize paper clips.
Understood. Maximize paper cuts. Initiating now.
Wait, what? No!
All right, so that's the first one, and this is the. Paper cuts all over his fingers. So that was my stupid little joke that I did with Sora. I got this free account, right? They got these promotion and all this, and the free account, when I did these videos, it would only go up to 10 seconds. They increased it now to 15 seconds for me. I don't know if why they did that, but the first ones could only do 10 seconds at a time, so I had to do two episodes, the 2 10-second episodes of the thing. And the first episode was the guy typing in that he wanted to maximize paper clips, and the AI said, "Okay, maximize paper cuts." Anyway, so that was my deal with Sora. Did I do another one here? Maybe I did another one. Excuse me. Oh man, what time is it? How long have I been out here? Too long? Almost 2 hours. All right, and I did another one here. Yeah, I did do another one. All right. So those were. So this is my. This is my account, KXQE. I got no views on this one. I don't know why I've got no views on this. I don't know what. YouTube does weird stuff to me. They put that it has fewer views than it actually has, to discourage me from making more videos. For some reason, they don't want me I don't know. I don't know what it is. They do that to me. But here's another one that I made. Let's see here. This is a short that I made. I did this one in vertical format instead of horizontal format. And if you're on YouTube or anywhere where they're doing videos, if you're on Sora, then you know what's going on. Everybody's making these short little video clips, and a lot of them are getting onto YouTube, and you'll see them. But I did this and this other little satire here on the whole thing. I'll play this one too.
Okay, just drag the cat clip. Easy. Huh? What? No.
More video clips, please. So many to enjoy. Endless clips forever.
Okay, just drag the cat clip. Easy. Huh? What? No.
This is let me stop that. This is I'll show you how I made this one. What I did is first I went to ChatGTP, and I typed, let's see, I typed into ChatGTP, I typed this into ChatGTP here. I said, please write a Sora 2 prompt for a 15-second comedic story about a video clip apocalypse. Include an image of a paperclip subtly placed inside each video that is featured within the Sora 2 story. So that's what I told instead of me, you get what I'm saying there? Instead of me typing up a prompt in Sora to make the video, I said, well, ChatGPT can write the script for me, right? So I just typed that one sentence thing into ChatGTP, and then ChatGTP output this prompt here for Sora. It output all this with all the details, and it gave it a name. It made up that name. I put the word video in there. It just had Clipocalypse or whatever that word is. But I put the word video in there, and I made a couple other little tune-ups to it. But basically, that's it. It produced this whole script, this whole prompt for Sora. Then I took this whole Sora 2 prompt that ChatGPT made up. Then I took that and fed that into Sora, and then Sora made this video here.
More video clips, please. So many to enjoy. Endless clips forever.
And it did the laugh track and everything.
Okay, just drag the cat clip.
It's kind of stupid, obviously, it's an AI. It doesn't have a sense of humor. It doesn't understand what's funny or what is. I think it's funny that it just is able to do that, at all. It's not funny. Comedy's hard, right? So I don't know. So it wasn't. I didn't think that was particularly funny, but it was interesting that. Although it was my idea to conflate video clip with paper clip. That was my idea. So I don't know if the ChatGPT could ever figure that out. I haven't seen it anywhere. I don't know if anybody figured that out yet. I'm sure somebody must have figured it out by now. But if you've been to Sora or you've been on YouTube and you've seen these, there's this flood now of AI, short little AI video things that are just all over the place now. That are funny and they're like things that are not possible. Let me see. I'm just going to type this in just for fun here. Sora 2. Let me see what we get. Okay, we've got some stuff here. Hang on just a second. All right. That one's sponsored. Let's see. This video is all AI using Sora. All right, let's see what this is. I have no idea what this is about. Let me open it up. Hopefully it's twitchable.
Is this the future of content creation? Meet OpenAI's Sora 2, the next evolution of video generation. With just a few words, you can create hyper-realistic videos of literally anything you can imagine, as long as it's within their guidelines, of course.
She's about to turn tech into a weapon.
I hope you backed up your data.
That's for spamming my inbox.
Been testing it for the past few days. It's so mind-blowing.
Well, this is more than 10 seconds.
Simple sentence can transport you anywhere, anytime, in any scenario you dream up. I've made so many wild videos that looking at my normal content creation seems so boring compared to this.
The first step is building your avatar. You just read a short string of numbers, move your head around, and within a minute, Sora 2 generates...
Okay, that's none of that's on the free account. But let's see what this one is. Ranking best Sora 2 AI videos. Oh, okay, here's one that's... Let's see what this is about.
Your chicken's looking nice, pal. Hey,
woo! Yo, he stole my chicken!
Got a crispy treasure, can't slow me down. Hot and golden, I'm out at this town. Move, move, Friday, victory.
Well, get back here.
Evening, sir. Step away from the car, please.
Oh, hi there. Just giving this old boxcar a little bit of love. A little mountain, some happy trees, nothing to worry about.
I get that, but you can't be painting on railroad property. Set the brush down.
Hawking at the top, wins perfectly still. Here he goes. Rolling, smooth out of the gate. Great speed! Launch! Huge off the table! He's flying! Look at the distance meter, it's still climbing! 140.
Evening, sir. You know why I stopped you?
I was not speeding.
40 and a 25. License and registration, please.
This is ridiculous.
Sir, hang on. You look like...
Stand by, I know who this guy is.
Don't even think. Hey, stop, stop.
Evening, fellas. Mind keeping your hands where I can see them?
Ain't no problem, officer. We just cooling. Yeah, we good out here. What's up? Something wrong?
Just a routine check. Need to see some IDs.
I got you.
Same here. 1 sec.
Here you go.
Appreciate it. Your chicken's looking nice, pal.
Okay, I don't like what they're doing there. So anyway, so they just got, you know, and I found quite a few out there that I thought were racist, like they're, you know, some of those. And I'm reporting them when I see stuff that's racist like that. I'm going ahead and reporting it because that's TOS, and I don't like to see racist stuff out there. So another thing you see is this AI slop. They use the word slop for AI slop. So whenever I find somebody who is calling AI generated content slop, then I come in here and I go like this, and no, I don't say report. Let's see what I do here. I go, how do I make this? Oh shit! There should be a way to tell it that I don't want to see this anymore. Report, add to queue, save, watch later, save, report. If I say report, no. Huh. Well, shit. There's supposed to be a way to tell it that you don't want that content anymore. Maybe I've got to actually open it.
Imagine bringing your side project to life.
Stop. I told you to stop, god damn it. They want to play the ads no matter what. Let's see here. Thanks, clip, report. Why do they... Now I can't remember how to do that. I had it figured out here, how to stop stuff from coming up that I didn't want to watch anymore. And they're not letting me do that anymore. I used to be able to click right here and say, don't show me this anymore. And now they don't put that up there anymore. So I don't know why that is. Give me a single reason why Sora 2 should exist. See, here's another one who's anti-AI. But I want to tell it that I don't want to see that in my feed anymore. Oh, you know what it was? Because I typed in a search thing. That's why. I think I have to come up here. That's what it is. It has to give me my normal feed stuff. if I actually search for something, it'll tell me. Let me see if it tells me anything here that's so you can see what my algorithm looks like. It's all geek stuff, and you know. It's not. What's interesting is it's not giving me Sora videos in my actual algorithm here. It's just giving me, you know, tech stuff and stuff like that. Just kind of interesting. We never know what anything means. I don't know what that means. Anyway, so let me search for some more Sora 2 stuff here. You know what I think is going on? Why there's so much offensive stuff that they're doing with Sora 2 is because here, commentary. Okay, I'm going to explain what I think is going on. You know, they had a lot of Hitler and a lot of racist stuff, and you know, and on this Sora 2, I think what's happening is people who make a living by generating videos and content and stuff like that feel threatened, rightfully so. They're not. You know, now anybody, it's democratized now. Anybody can do this, right? Anybody can make videos now. And before it took some effort and it was hard and you had to have some talent and blah 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 to produce videos. Now anybody can do it. So all these you know, YouTubers that got billions of followers and all, or millions of followers and views and all this, they feel threatened. They don't, because they're going to lose their standing, right? They're going to have a lot more people competing with them now. So they don't like that. And what they're doing is they're going out there and this is my theory, okay, that they're going out there and producing very offensive Sora 2 content, racist content, and, you know, stuff with Hitler and all this kind of stuff, and putting it out there to make people think that there's bad stuff. And I think that's a lot of what this slop, you know, using the word slop is a dog whistle to creators to tell them to go out there and make offensive content under the Sora 2 brand. I think that's what's going on here. And I think that's why when you go to OpenAI's Sora 2 website and you try to make video, you know, they've got a pretty draconian filter on it right now. They're trying to prevent that from happening. They're trying to prevent this onslaught of people who are threatened by this new technology, who want to sabotage their brand and their videos and stuff. So they're trying to filter that out. I think that's what's going on. Anyway, that's my theory. But what do I know? I got social dyslexia. I don't know how that stuff works, right? All right, so here's this guy here. Sort of to give me reasons why this, blah, 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 blah. Okay. It's too real. What is this here? There's somebody crying. Yeah, another thing that when you go to the Sora 2 website and start looking at these videos, like there's somebody out there who is just doing nothing but having people yell, which is very irritating, right? It's irritating to have somebody just yell, right? And so somebody has gone out there and is producing video after video after video of somebody just yelling on the video, you know? And it's just to sabotage the feed, to sabotage the experience, and everything. So, but fortunately, you can go in there, and there's a little button, right? When you see it's not that many people who are doing it. Maybe they set up multiple accounts or whatever, and I'm sure that OpenAI could figure that out and track IPs and all that stuff. And so when you go to the Sora 2 website and you see this racist, offensive, all this videos, just ban. Okay, don't show me that anymore. Ban this guy, and they have a thing where you can say, don't show me things like this. Don't show me videos like this anymore. And it doesn't take too long to go in there and just ban the ones that are doing the racist stuff. And also that'll help OpenAI. That'll help them sort out who's trying to sabotage their business. Okay, here's one that does. Let's see what this is. No, I don't know what that is. Oh, there's a whole bunch of these that are doing trick or treat, and I'm sure there's some figurative meaning to that. But they do a whole bunch of trick or treats where they have different. They have snakes and alligators and all different people coming up and doing trick or treat. Let's see, show more shorts. They're all going to be shorts, right? There's another Hitler, right? You don't want that. Proves the AI bubble is going to burst hard. See here, this guy here. He's a big name. I don't know if you've heard of him or not, but he's got a lot of views. He's got a lot of followers. He's a big YouTuber. He makes a lot of money on YouTube by making content on YouTube. All right, this guy here. Adam Conover. This guy makes a ton of money from YouTube, from putting up YouTube videos, producing them, editing them, and all that stuff. So now anybody can make these videos now. Anybody can go out there and make cool videos. They've democratized this process even more now. So people who have ideas for videos and maybe didn't have the skill or the money or whatever to be able to do it are going to compete with these guys, and these guys are pissed about it. They don't like it. So he's out here saying that he doesn't like it. He's saying he doesn't like it. Oh, it's slop. The bubble's going to burst. Blah blah blah. And they're all in denial, They're all in denial because their business model is that's what's going to burst is their business model, their monopoly or their oligopoly or whatever on on making videos now. They're not the only ones out there. Everybody's it's out of hand. Here's one right here's somebody with a whole ton of views. Right, I don't know who this is. Like the Snake. Who the fuck knows who this guy is? But he's got a lot of views, presumably a lot of subscribers and all that. He's upset about it. It's out of hand. It's But here's one. Here's a guy with smaller views, right? I don't know who this is. Ert. He's saying the future of reality. This is cool. He's saying positive. This is great. So when you're out there looking at these things and you're hearing people report, I can only imagine what mainstream media is reporting. I don't watch mainstream media anymore, but I can only imagine what they're reporting on this now. This AI videos. I'm sure they're dissing it up and down. They were already pissed at YouTube. They were already pissed at the internet. If you I don't know if all you ever watch is TV, I can only imagine what people who watch TV what they're is getting fed into their brains about what AI and this is all about. But they're threatened by it. It's anybody can make these videos now. And so, banned Sora 2 AI videos that you can't make anymore. Yeah, well, they're banning it for good reason, right? They're banning it because people are trying to sabotage their business. That's why. All right, I don't care. Abusing it. So they're going to say all the bad stuff, right? They're going to show these guys who have, you know, lots of viewers are going to put stuff out here saying how bad it is. All right. It's not what you think. So maybe I should go to the actual website. I think I can do that. Can I do that? Let me do that. Let me try to go to the actual website. I read the you know, the terms of service, and they said it's okay to stream it if you're like demoing it or whatever. So okay, so here's, let's see here. This is what the website looks like. Okay, right now. It says for you. I don't know what that means, but this guy right here, this guy.
I'm geeked out! I'm geeked out! I'm geeked out! I'm geeked out!
Somebody, I don't know who this is, but he has gone through and he's just making a whole bunch of these videos of this guy just yelling on the video, right? And it's just to irritate people. That's the whole point. Let's see here. Let me click on this. Report. See less than this. See? So you just click this. We'll show you less of this content. So all right, let me reload the page. Oh, let me do this in case it doxes me.
I'm geeked out!
Well, it's still showing it to me, so I don't know.
About it. Mom, how many cats do you have? Don't worry about it.
Let's see, here's somebody's out there doing a whole bunch of these Halloween things where they have all different animals and stuff coming up to do trick-or-treating. Hollywood theme. Somebody did that whole action. Oh, this one, wow. I want to see what if they put the prompt in here. Okay, no, they didn't put the prompt in here. Sometimes you can get. Oh, here it is. Make a movie. Okay, so this what they did here on this one is they had. So it took them multiple tries to do this, right? They started with. Okay, so they started with a pickle. They tried all different things here, and they keep they're doing what they call remixes. They take a video that they made, and then they say change it to do this instead, right? And they keep doing that, and they keep improving the video or making it closer to what they want.
I'm geeked! 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 I'm geeked!
You never believe why they kicked me off the plane?
Here's another one that's a theme.
Get out of here. That's right.
They show a lady on her front porch.
What? Get off my porch.
Kicking
Shoot. Go
various
on now.
animals
I said
and
leave. Don't you snort
vehicles
at me.
or people or whatever
Get out of here.
away
That's
from her
right.
front
Don't come
porch.
back. Hey,
That's not good.
what?
That she's
Get off
treating
my
that.
porch.
On stone, hold man them in line. Voice of the block. Sign from the curb to the capital, truth in my tone. March with the people, we claiming the throne. Pan on stone, hold man them in line. Voice of the block.
So they take it.
Still
This
grip
one's
to the grind, can't
racist.
chat about
Okay,
peace if you.
I'm gonna
And on stone, hold man them in line. Voice of the block, got a dream in the spine. Hope in the chest, still grip to the grind, can't chat about peace if you're ducking the sign. From the curb to the capital, truth in my tone.
They don't.
March
They
with the
don't
people,
even
we
have.
claiming
They
the
don't even
throne.
have a thing for
Pan
clicking
on stone,
for
hold man them in
racism.
line. Voice of the block, got a
So
dream in the
just
spine.
harassment,
Hope in
I
the chest,
guess,
still
I'll
grip
put
to the
down
grind,
there.
can't chat about peace if you're ducking the sign. From the curb to the capital, truth in my tone. March with the people, we claiming the throne. Pan on stone, hold man them in line. Voice of the block, got a dream in the spine. Hope in the chest, still grip to the grind, can't chat about peace if you're ducking the sign.
See
From the
what they
curb to
did
the
here?
capital,
They
truth in my
take
tone. March with the people, we claiming
Martin
the throne.
Luther King, most,
Pan on
one of
stone,
the
hold
most
man them in
eloquent
line. Voice of the block, got a dream in the spine. Hope in the
people
chest, still
on the
grip to the grind,
planet.
can't chat about peace if you're ducking the sign. From the curb to the capital, truth in my tone.
Whoever lived
in this about peace.
and they make him sound like an illiterate rapper or whatever, So there's a whole bunch of that out there. There's a whole bunch of this racist content out here. And a lot of it is junk, but some of it's kind of funny, But anyway, that was that's why I did that. That's why I did this this video that I did, right? Or is it shorts? That's why I did this video, because it's just funny.
Okay, just drag the cat clip. Easy. Oh, what? No.
More video clips, please. So many to enjoy. Endless clips forever.
Okay, just.
All right. Anyway, so that's what's going on. If you haven't been, you're not into that, or you haven't, that's what's going on out there. My take on a dynamic and what it's kind of a war zone right now, right? It's a disruptive technology, and so there are going to be a bunch of people who don't like that technology, who want to sabotage it as much as possible, and they're going out to the site and trying to sabotage it, trying to make bad stuff out there. Now, I don't know, I told it that I didn't want that some of that stuff, and it's still putting it up there for me, so I'm not really sure why it's doing that. Less like this. Okay, I tell it I don't want that, but it still puts it up there.
In this town, we all know.
Trunk's popping.
Maybe it
Let's
takes
see.
it a while for it to figure it out. I'm not really sure. Oh, here's that lady again. This one's with
Go
a,
on now. I said leave. Don't you spool up at me.
with an airplane, right? An airplane comes up to her.
Hey, what in the world? Get off my porch. Shoot. Go on.
Hey, record! 6, 7!
Oh, there's Marilyn Monroe and Shaq. Okay, here's a trick-or-treater again, the trick-or-treater one, right? With a snake instead. So anyway, it's mostly goofy stuff.
Mountains way down
there. That's pretty funny. They're gonna. What is it? Is that gonna play? That's not playing. Why is that not playing? Whether don't know. Yeah, somebody out there is really trying to diss Martin Luther King all over the place. A lot of racists out there. A lot of racists. So that's something you got to be aware of right now. And it's people, you know, that I think are just, you know, just trying to put offensive stuff out there, as much offensive stuff as they can in order to sabotage the whole thing. So it'll be like that for a while, probably until I don't know how much OpenAI is, you know, on top of that. I'm sure they understand, and we're expecting that and prepared for it. And you know, they even acknowledged. They said, yeah, the filters are kind of tight right now on the content. I don't think they're tight enough. I mean, you know, I'm more of a person who likes free speech and likes, you know, people to be able to do what they want. But what they're doing is they're trying to put things that are irritating, you know, and offensive. That's what they're trying to do right now out there. The people who don't like OpenAI and don't like Sora. So what they need to do, OpenAI needs to have tools that people can use to sort that out, and they need to get on top of it and figure out, you know, who are the accounts that are putting out the offensive stuff, and you know, make sure that their videos are not the first thing you see when you go to the site. You know what I'm saying? I don't know if they understand that. I don't know. You know, they're an AI company. You know, they're not a social media company. I don't know if they understand that. I don't know if they've, you know, got that figured out or not. Probably not. I think I made a comment on my last video. I think because I think I was talking about this on the last stream that I did a couple weeks ago, where I said that their strategy is to you know, they're trying to expand, right? They're trying to make more money, and one of the things they want to do is to try to make a little social media site out of this whole thing. So instead of just having a tool that people use to make videos, they can try to do a, you know, they got the power behind them and all that, and the size to create a network. If they do it correctly, they can create their own little social network out of it. And but it's not easy to do. You know, you got what exactly what's happening right now. They're being attacked, you know, by all these people putting crap up on their thing. And I don't know if they're probably not. They probably don't understand that. They probably don't understand what's going on. Or if they do, you know, if somebody in OpenAI understands that, maybe they're not, you know, in the position where they can do anything about it at the company. I don't know what the deal is. Or maybe they just know that this is happening, and they're letting people do that, and they're letting their AI track everybody, so that they can cut them at some point, you know, or degrade them or whatever, make sure that they don't put their videos on top or whatever. I don't know. We'll see what happens. I said it was probably 50-50 that they'd be able to successfully get this network, this AI video networking, social networking site going. I mean, it's pretty cool. They've got an amazing tool here. This is just incredible what this thing is able to do. But whether or not they'll be able to get to be successful or not on this, Weirdest videos. Here's one of the weirdest videos. Let's see what this is. Hopefully it's not too offensive.
With Liberty Mutual, you can customize your car insurance to save hundreds.
Could you look away?
Skip.
There's a man on the racetrack. That is Stephen Hawking. He's in a powered chair and he is flat out racing the field. He just passed the 11 car down low. He's holding 50. Oh my word! There's a man on the racetrack.
This celebration is unlike anything we've seen in Victory Lane. Stephen Hawking soaking up the moment, beer showers and all.
Introducing the hottest thing since ice, bag of water. Whoa. It's ordinary water locked in a see-through pouch. Shake it, stare at it. That's literally all it does.
Illegal.
You get one full bag for just $999.99.
Bag of what?
Let me tell you something,
Yeah,
okay?
these
you
are
don't
weird.
get rich hitting everybody on the block.
These
you
are
get rich
weird.
when you know who wants what you got. The right customer, he make the deal easy, man. You talk his language.
Evening, you know why I pulled you over? Wait, is that sliced ham? Sir? Step out of the vehicle for me. All right, off the wheel, buddy. Hey, don't. Hey, stop the car. Dispatch, driver just fled. It's a stack of ham. Repeat, ham driver headed west on chair.
Hawking's still out front. Look at that speed down the main street. 327 kilometers an hour from a wheelchair.
Yeah, there are a whole bunch of these videos of Stephen Hawking for some reason.
Wow, looks tasty. Give me that potato parade. Golden little drumsticks just got made. Salted sunshine. I'm the Fry King tonight.
Yeah, they take a whole bunch of people who are dead and make them come to life again.
Get back! No! Ah! My eyes! Ah! I can't see! Queso, no cheese! No queso, no cheese! No queso, no cheese! Back it up! No cheese! Break! Make the protest rain or shine! We get time and a half in overtime!
Getting paid to protest? No, people
All
don't
you
get
people
paid
talking
to
like
get
you know
to
me calling
protest.
every sort 2 clip AI slop. I'm sick of it. You think just because it looks too good it can't be real? Man, please. I work hard, okay?
AI
Real sweat,
slop.
real
So
hours.
here's
You want
somebody who
There,
doesn't
let's go
like
up to
it.
Skycam 7. Chris, what are we looking
All
at?
right.
Yeah, Dina, we're over the...
All right, I don't. That. All right. Oh, hey, I got somebody out here. Wait, shit. I gotta. I've been sitting out here for 2.5 hours without any chatters. So sorry if I didn't catch you right away. When did you guys get here? Sorry. For those of you watching on the VOD, let me see here. I gotta turn on my timestamps here to see when you guys were here. Let's see, timestamps. How do I turn on timestamps? Oh, geez, I don't know how to do this here. Yeah, I've been sitting here by myself without anybody in chat for over 2 hours, and so I kind of blanked out there. Sorry, guys. God damn. All right, let's see, shield mode. Hang on just a second. We'll figure this out. Subscriber only. Clear chat. Manage moderator. I'm trying to figure out how to figure out when you guys posted your messages out here. Show messages caught. Show my preferences. Pause chat. Huh. All right. Sorry about that. Manage moderation setting. There's a way to turn on not too long. Oh, okay, not too long ago. Okay, good. Thank you. I wasn't sure. As I said, I've been talking here for over 2 hours to myself. So I just kind of like, okay, this is going to be one of those streams, where you just talk to yourself. Thank you for coming. Welcome. Oh, that's right. I'm supposed to welcome everybody. Welcome to the stream. Welcome to chat. Snowy City says, I recently saw one where a heavyset delivery driver fell through a porch. Yeah, it looked fake. Yeah, some of them look real and some of them look fake. I mean, some of them, right, or they're fake just because of the situation or whatever. But some of them look actually pretty real. It's no longer going to be funny if you can make the video. It's no longer going to be funny. Yeah, it's interesting what's going to happen. You know, the sociology of the whole thing. You know, are people going to believe things anymore? And it's really something else. It's going to be interesting to see where it goes. America's Funniest Home Videos were funny because because it was before AI. Yeah. If you know it's real, then you know it. But even those, you know, some of those funniest videos or whatever, even some of those you could tell were staged, even though they weren't made by AI. You could tell that the people who made them staged them. You know what I'm talking about. Like they pretended like they fall or whatever. You know, some of them anyway. Eram says, I'm so old, I remember the original TV show, Candid Camera, yeah. Candid Camera, Alan Funt, yeah, I remember those. That was one of my favorite shows when I was a kid, young, whatever. I remember some Candid Cameras when I was young, but I'm younger, a younger whippersnapper, as Snowy City says. And Eram answered him, yeah, younger than me. Ads back, yeah. I've been kind of blowing through the ads because I didn't have anybody watching. But maybe I'll pause on the ads now. Snowy City, I see your point. And that's my bot trying to say something. Yeah, do you guys want to see some of the videos that I made? Let's see. Eram says yes. In later years, many are staged. Yep. That's what I liked about early Candid Camera. Yeah, it was all real. Yeah, the early ones were real. Yeah, it was back in film. They didn't even have, you know, it was like just a tiny fraction of a percent of people even had a camera, you know, like an 8mm camera or whatever. Nobody even knew anything about it or anything. Yeah, it was kind of interesting. It was more natural and real and stuff. I'll play you a couple of them that I made. Did you guys see the ones that I made? I don't know if I was. Let me find my. Okay, here's one that I made. This right here is like a meta satire about the whole thing. It's this thing here. Let me see. I'll play this one.
Drag the cat clip. Easy. Huh? What? No.
More video clips, please. So many to enjoy. Endless clips forever.
Okay, just drag the cat clip. Easy. Huh? What? No.
More video clips, please. So many to enjoy. Endless clips forever.
All right, so that was one clip that I made. It was just one video that I made. I typed it in. Let's see. So that obviously was a video satirizing what's going on right now with all the videos out there. What did I do? Oh, I did another one. Here, let me see. This is. I'll just show you here. Did you guys see this already? The laugh track, yeah. It did, and I didn't tell it to put the laugh track in there. It did it all by itself. It put that laugh track in there. Here's another one that I did that satirizes this whole thing, or it satirizes AI anyway.
All right, AI, let's do this. Maximize paper clips.
Understood. Maximize paper cuts. Initiating now.
Wait, what? No!
Okay, so that was... So the guy... Are you guys familiar with the paperclip apocalypse thing? That's kind of an inside thing. I don't know how many people are aware of that or what. It's... There's this deal with AI that a scenario where if they say we're worried about AI not doing what we tell it to do exactly, you know, or doing or having it do exactly what we want when we don't want it to. You know what I mean? So there's this scenario where they say somebody who runs a paperclip factory somewhere types into their AI to maximize the production of paperclips for their paperclip company, and then the AI goes out and ends up taking every bit of matter on the whole earth and turning it into paper clips, right? They call it the paperclip apocalypse. And so I did a video about that. So that was this guy here. He goes and he types into the thing that he wants it to maximize paper clips, but it misunderstands. It thinks clip is cut. And so,
all right, AI, let's do this. Maximize paper clips.
Understood. Maximize paper cuts. Initiating now.
Wait, what? No!
So it maximizes paper cuts. And that was episode 1, and this is the season finale. Everybody's got paper cuts all over. So those were two that I did. A couple that I did. Let me show you the very beginning. I want to do this now on my. Let's see if I can get this. All right, I'll show you what the stream looked like at the very beginning. My stream here. It'll just take a second here. I'll cut the opening short, but you'll see what happens here.
Oh, hi. This is the Double Tribble channel. My name is Ron, and I live in rural New Hampshire, surrounded by forests and wild animals. Wait, I'm still a cartoon. Hold on.
That's better. There we go. I'm no longer a cartoon now. So that was my I did a little video. I took all I did was take that still cartoon image of me and gave it to this AI and said, make it talk, and it did all that and made it talk and everything. So I thought that was kind of funny. So it's fun. Have you guys fooled around with that at all, or I don't know? Are we running ads? No. It's really easy to use. So if you want, you should go out there and mess around with it if you can. It's so easy to use. It's just Sora 2. You type in OpenAI Sora 2, and you can get to the website. It's pretty easy. I think you still need an invite code to do it if you want to. If you want to do it, I don't know if I can get an invite code. If anybody wants one, maybe I'll figure out. If you want an invite code, let me know, and I'll see if I can figure out if I can get one or not. But you might need because it's by invitation only for a while. But we'll see. I don't know. But it's very, very easy. It's just like you just go there and you say, make a video that does this. Make a video that makes a rhinoceros that runs through a grocery store or something, and it'll do it. It does whatever you tell it to do. It'll make that video for you. It's really amazing. So let's see here. Doesn't. How dark energy? Okay. All right. So right now it's a lot of junk though. So we'll have to get through this battle that they're going through right now. A lot of people are out there, just people who make videos for a living are going out there and trying to make and the thing is that the people who genuinely want to use it and, you know, do it for good and all that stuff, and are not trying to sabotage it, you know, don't understand as well how to, you know, how to make videos to begin with. So that maybe they're not as good at using it as the people who are making a living on making videos. So the people who are making a living on videos can make higher quality AI videos, but make them super offensive, that, you know, to try to reinforce this narrative that it's you know, there's something wrong with it or whatever. Let's see. Create stunning video ads in minutes. Look at this. Minutes. It's seconds. It's not even minutes. It just takes a couple seconds to do it. Here's somebody how to create a viral. How to create viral. Look at this one. Oh shit, that's not right. Wait, hang on a second.
Oh, hi.
Sorry.
This is the Double Tribble channel. My name is Ron, and I live in rural New Hampshire, surrounded by forests.
Hide your sources. All right. Here's the guy says how to create viral Sora 2 AI videos step by step. And he's got 600 views on his, so I don't know. Sora 2 Pro. Look at these. God, look at all this stuff. Introducing Sora 2. Here we go. Let's see this. Oh, that's a 20-minute ad. That's a 20-minute video though. I don't know. Maybe it's got some. Maybe they got some things in here.
Monday.com, the opposite of any work platform we tried in the past. We tried other work management platforms, not naming names. They all suck. Monday, total opposite.
There goes.
1 year ago, Sora 1 redefined what was possible with moving images. Today, we're announcing the Sora app, powered by the all-new Sora 2. It's the most powerful imagination engine ever built.
All right, I'm trying to play a this demo, this basically ad from Sora 2 on their product, and then Twitch ran ads, so I've got to pause on Twitch so people can watch the Sora 2 ad. If you're watching on the VOD, I'm waiting for Twitch to complete an ad right now. Got about another minute, so we'll wait for that. It's a Trivago ad, and then I've got a L'Oreal. Why? What, really? Why L'Oreal? Why? How could anybody think that people watching my stream would want makeup? Would want L'Oreal makeup? You know? That's the ad they're playing right now on Twitch. L'Oreal Paris. Right? Yeah, that's my audience. Yeah, it's people who want makeup. I don't know. Now, a pizza ad. Yeah, that's probably a little bit closer, except I'm vegan and they're putting all kinds of dead animals on their pizza and showing that. So that's, I don't know. All right, so we're back here. Let me continue this this Sora 2 video. Show that.
And it's packed with new features. I'll pass it to Bill for more details.
This stuff looks kind of tame.
Now every video comes with sound.
Sora 2 is also the state-of-the-art for motion, physics IQ, and body.
Now that looks pretty realistic,
marking a
right?
giant leap forward in realism.
A guy in a snowmobile, you know. That looks real. Yeah, and that one there looks kind of realistic, right? Somebody's ice skating.
And we're introducing Cameo, giving you the power to step into any world or scene and letting your
This looks
friends
kinda
cast
fake.
you in theirs.
On the path to AGI, the gains aren't just about productivity. It's about creating new possibilities.
It's also about creativity and joy. 1, 2, 3, 4.
All right. Well, it's a 20-minute video. I don't want to play. You can go to YouTube here. Just go to the OpenAI channel on YouTube. OpenAI, pretty easy to find, I'm sure. And then you can watch that if you want. There we go. All right. So that's videos. I'm working on some other ones too that I want to use on the stream here, on my Twitch stream. So once I get those figured out and get them, integrated into my stream and all that, I can play them on my stream. I have all of these little things, these little videos that I put on here that are clips.
Completely unscientific, absolutely absurd, violates every rule of common sense, and is completely contrary to the rules of logic and intelligence.
So I've got that one. Here's another one.
Are we there yet?
Not yet.
Not yet. No, we're not. We're not done yet. So anyway, I did a whole bunch of those type of things. But they're all like clips, from out of context, whatever, stuff.
Let's try something different.
They're kind of funny, but maybe what I could do is, make up some of my own videos, of stuff, and maybe even customize them, for like for specific people who come to my stream, maybe make videos about them. I don't know if people would like that or not. I don't know. Maybe I shouldn't do that. With my social dyslexia, I'd probably screw it up somehow. Say something. People would get offended at that. But anyway, you can do custom stuff, with it. So, all right, that's all I was going to talk about, I guess. Unless somebody has anything else or has any questions or anything. Let's see here. God, I wish I could figure out how to make this display the way I want it to display, but it's not going to let me do that. No. All right, so we talked about gravity. We talked about mistakes that I made on previous streams that I wanted to correct. And so on my next stream, maybe that should be maybe it should be a regular part of my stream now. Corrigenda, fixing mistakes I made in previous streams or something like that. I don't know. It's kind of silly, but I'm trying to think if there's anything else that I needed to talk about. And I don't remember if there was or not. I guess I'll do it on the next stream. It had been a couple weeks since I did a stream, and you know how Twitch, when your stream, when your videos get old enough, they kind of kick them off and they don't show them anymore after a couple weeks or whatever. And all of my videos had gotten kicked off, so I didn't have any videos showing. So every time somebody went to my channel, there was nothing there. It looked like I wasn't a streamer anymore. So I had to do a stream here just to make it look like I was a real streamer. So I decided to do a stream on gravity and all this other shit. So, all right, I guess that's it. Now I'm going to try to play my closing here. And I suspect it's not going to work right. And if it doesn't, then I'm going to have to do it another way to get my credits on here. So I'm going to try to play my closing, but it might not work. If it doesn't work, then I'm going to interrupt my closing and do something else. So, all right, everybody take care. Bye. Yeah, that didn't work. It's not doing it right. All right, let me see here. Shit, this isn't working at all. Sorry. Oh my god. Let's see here. Alright, let's put me back on here so we get something. I'm trying to get my Alright, we got that. Sorry. I can't even stop my stream right. Alright, closing. No, that's not what I want. Got that on there. Oh, here we go. Okay. All right, here it is. Okay. All right, these are my credits, because the frickin', for some reason OBS is not. This is supposed to play. These credits are supposed to scroll at the end of my video, and they didn't scroll, and for legal reasons. I don't know why. I want to make sure that I have my credits up here at the end of my video. So here's my credit roll. There you go. See it scroll? Oh, so there's all my credits. All my legal stuff. Yeah, fair use, blah, blah, blah. Don't sue me. Sue somebody else. All this stuff. There you go. All right. All right, now I can play my closing there. All right, thank you, everybody. Bye.